Use the formulae and tables to express cos of 2a and sine of 2a in terms of t equals tan of a. Hence, show that 1 plus sine of 2a divided by cos of 2a is equal to 1 plus tan of a divided by 1 minus tan of a. So we're going to use the double angle formulae from page 14 of the tables. So we're going to start with cos of 2a is equal to 1 minus tan squared a divided by 1 plus tan squared a. And what we're going to do is replace every tan of a with a t. So this tan squared a becomes t squared, and this tan squared a becomes t squared. So you end up with 1 minus t squared divided by 1 plus t squared. Next we're going to use sine of 2a, which is equal to 2 tan of a divided by 1 plus tan squared a. And again, replacing every tan of a with t. So this tan of a becomes t, and this tan squared a becomes t squared. So we end up with 2t divided by 1 plus t squared. Hence, show that 1 plus sine of 2a divided by cos of a is equal to 1 plus tan of a divided by 1 minus tan of a. So in part 1, we worked out that cos of 2a is equal to 1 minus t squared divided by 1 plus t squared. And we also worked out that sine of 2a is equal to 2t divided by 1 plus t squared. So hence means using what we found in the first part. So the left-hand side of our equation is 1 plus sine of 2a divided by cos of 2a. So we're going to have 1 plus sine of 2a divided by cos of 2a, and we swap the sine of 2a for 2t divided by 1 plus t squared, and we swap the cos of 2a on the denominator for 1 minus t squared plus 1 plus t squared. So we end up with 1 plus 2t divided by 1 plus t squared, and all of that is divided by 1 minus t squared divided by 1 plus t squared. So since we have a fraction that has a fraction in the numerator and in the denominator, and both of those smaller fractions have a denominator of 1 plus t squared, we're going to multiply above and below by 1 plus t squared so that we can cancel out the denominators. So 1 multiplied by 1 plus t squared leaves us with 1 plus t squared, and then 2t over 1 plus t squared multiplied by 1 plus t squared. The 1 plus t squareds will cancel out, leaving us with 2t, so we bring the 2t down here. And that's all divided by, in the denominator, the 1 plus t squared will cancel out with the 1 plus t squared, leaving us with the numerator, which is 1 minus t squared. But that actually goes into the denominator. So we have 1 minus t squared in the denominator. Next, what we're going to do is we're going to factorize. So factorizing the numerator, we have 1 plus 2t plus t squared, which we can rewrite as t squared plus 2t plus 1. We have two sets of brackets, t in the front of each, plus 1 in the back of each. So we have t plus 1 multiplied by t plus 1. Next, we're going to factorize the denominator. So it's actually going to be the difference of two squares, because 1 is a square number, t squared is a square number, and we have a minus in between. So the square root of 1 is 1, so we have 1 in the front of each of our brackets. The square root of t squared is t, so we have t in the back of each of our brackets. 1's a plus, 1's a minus. So we have 1 plus t multiplied by 1 minus t. We have t plus 1 in the numerator and the denominator, so they can cancel each other out. So you're left with t plus 1 in the numerator and t minus 1 in the denominator. So we end up with 1 plus t divided by 1 minus t. And remember, we let t equal tan of a. So we're going to swap each of those t's now for tan of a. So we get 1 plus tan of a divided by 1 minus tan of a. And that is equal to the right hand side. And that is what we were asked to show.